Hi, in this video, I'm going to explain selection of statistical tests depending on data type. Okay, in the next few slides, I'm going to break down the slide into more simpler concepts. Starting with the first slide, the difference between independent variable and dependent variable. So independent means it's not dependent on other variables, and it can be manipulated by researchers. For example, you select a group of people whose BMI fall between 25 to 30. So it can be manipulated. This other one is dependent variable, and this one cannot be manipulated. Just it's a measured value. Let's make a classic example, the BMI and the A1C level. It makes sense that there's a direct relationship between the two variables. So the A1C level is measured, cannot be manipulated, but the BMI can be manipulated. You can get guys with normal or higher BMI. Okay, the second concept is difference between categorical and non-categorical. So for the categorical variable, it has a finite number and doesn't have intrinsic logical order. For example, blood pressure type A is categorical. If it's numbers like 120 over 80, now this one is non-categorical or quantitative. Okay. The third slide is the difference between correlation and regression. The correlation is simple relationship between two variables, like continuous variables, and it lies between positive 1 minus 1. Positive 1 indicates strong direct relationship, minus 1 indicates strong inverse relationship or negative relationship. If it's if it's a zero value, there is no linear relationship, so the curve will look like this. So here's x-axis, the independent variable, and y-axis, the dependent variable. Okay, the regression analysis is about mathematical relationship between x and y. So let's see in this slide, there's a correlation analysis, and there's a direct relationship. The R value or the coefficient of the correlation may be equal to, so it's a positive value because it's a direct relationship. It's not the perfect curve, so it may be like 0.7, for example. And another curve here for the regression analysis. So there is a mathematical equation. For example, the y is my axis here, is the dependent variable. You can measure this value based on the equation. Okay, regression analysis has two types, linear, as described before, and logistic regression, and it's described as the y-axis. So we indicate some values such as 0 and 1. For example, let's say BMI and diabetes. And if the patient has diabetes, you refer to as 1, the value 1. If there's no diabetes, you include 0. So it looks sigmoid or S-shaped, while the linear regression is just linear shape. Regarding the t-test, there's two types, one sample and two sample test. And the two sample further subdivided into unpaired and paired test. The unpaired are two groups at the same time, but the paired test is just one group at two different times. For example, let's say time 0 and after 3 months. So we measure the difference in the scores. For example, let's say the score grades now and after 3 months. So we compare the mean values. We use the paired test because it's just one group. The ANOVA is just similar to t-test when we're talking about just two groups. But if it's more than two groups, like 3 groups, we just use ANOVA test. So ANOVA and t-test, we use quantitative values, like the mean difference. Okay, the categorical tests include chi-square, Fisher exact test. It calculates proportions to groups. So proportion of people with diabetes in group A and group B, such as group A is 50% and group B is 60%. Okay, and Fisher exact test, it's similar to chi-square, but we use fewer number, like 10 patients.